able to come up with the logical reasons on why something is happening the way that it is happening. The ones that we are aware of, you learned back in algebra, which are all of these guys. So our algebraic properties of equality. Oops, come back. So our first one we have is the addition property. What do you think the addition property looks like? Yeah, using addition. So I'm going to use actual numbers because I feel like that will make more sense for you guys. So if we had something like this, if x minus 5 is equal to 6, I didn't realize how big I was writing that. I'm going to write that a little bit smaller so I have space. If x minus 5 is equal to 6, then if I use the addition property, what would x equal? Nick?
Would equal 11.
Yes, that's okay. It's a Friday morning. I'm with you. I got a black and a brown flip-flop on this morning, so I'm right there with you. Okay. So how did I get from this hypothesis to this conclusion? I added 5 to both sides. Right? Yeah? I'll just do it really tiny. Add 5, add 5. So we use the addition property to get over to our answer of x equals 11. Okay? So that would be an example of the addition property. For our subtraction property, if we did something like if x plus 5 is equal to 6, then what would x equal? Stephen? Good. X is equal to 1. Because what did we do? We subtracted 5 from both sides of an equal sign. Okay? Do you guys know how to do this? Because you learned this back in the beginning of algebra. It's just now we're remembering what the properties were called that you were using in algebra. Okay, so multiplication. If x divided by 2 is equal to 10, then what would x equal? Half of what is 10? Try again. Half of what is 10? 20. Good. Half of 20 is 10? Because how do I get rid of a divide by 2? We multiply both sides by 2, right? Get that cursor out of there. So multiplication, if you multiply both sides by something, then that's multiplication property. Division. If 2x is equal to 10, then your x would equal 5. Because how do you get rid of the 2 in front of the x? You divide it out, right? So that's the division property. Okay. All right. And the last one we have is the substitution property. And the way that you guys are going to see the substitution property is something maybe like this. If 2x plus 5 and x is equal to 3, what do we do when we substitute something in? We plug it in place. So then 2 times 3 plus 5 would equal, what is that, 11? Yeah. 2 times 3 is 6. 6 plus 5 is 11. So when you substitute something in place of it, it's the substitution property. Okay? So what's going to happen for the first part of section 2.5 is you're going to be given an equation. You're going to have to solve that equation for x and justify each step. Okay? Now you do not need to show all the possible work. The first one we have set up does kind of show all the work, and I'll show you how we can kind of condense it a little bit as we go. So we have this written down? Okay, so for our first one, here's our equation. The equation we're starting with is 3x plus 8 equals negative 4x minus 34. What would be the first thing that you would do to solve this for x? You probably would do what? Move the 4x over to the other side by doing which property? Or which operation? Addition, right? Because that's a negative 4x. So if I look at the next line here, notice here they added 4x to both sides. So which property is that? The addition property. And you can just put prop for property if you don't want to write it out. Your first line, I skipped that, should always just be written in as given, because that's what's given to us to start out with. All right, so then what happened from line 2 to line 3? Nick? They simplified, because what did they do? They combined the 3x and the 4x to make a 7x. And they combine a negative 4x and a positive 4x to go away to a 0x. So we're just going to write a plain old simplify. If you wrote combine like terms, I would totally accept that too, but we're just going to use simplify as our generic term of putting things together. Okay, so now from this line, what would you do next? Subtract 8. Notice that's what happened here. We subtracted 8 from both sides, so that would be which property? Subtraction property. Then our next line would be a, not yet. What happened? A simplify. They combined their like terms, and then you have it, Lauren. Then they did a division property. Okay. So, an algebraic proof. You all should hopefully know how to solve an equation, hence why you have passed algebra and now are in geometry. So now we're going to justify it by giving it a property on the reasons side of our 2-column proof. Okay, so we're going to add another property to our tool belt. You did this a lot in your homework. The distributive property. Your distributive property would be something like if 5 times x plus 2, then when you distribute it, you would get 5x plus 10. Okay. So be aware that you may have some problems that involve the distributive property. So once you have that, flip onto the back. So now we're going to set up our own 2-column proof. Steps are not provided for us. All right, so for this equation, let's go ahead and set up, I'm going to say a T-chart very often. Set up your T-chart. So just kind of make one big long bar. That was not very straight. I can do better. And then one bar down. We always have our statements on the left. And we always have our reasons on the right. Me personally, I like to number my lines just to keep myself a little bit organized. So line 1 is going to be what's given to us, which in this case is an equation. So I'm going to just rewrite the equation. So 60 equals negative 3 times 8x minus 4. And over here I'm going to put another number 1 and write the word given. Okay. All right, so line 2. What would you do first to solve that equation? Distribute, right? So let's rewrite it after distributing that negative 3. So the 60 is going to stay a 60 equals, what is negative 3 times 8x? Negative 24x, good. Negative 3 times a negative 4 is positive 12. So over here, I'm going to justify it with a reason, which is the distributive property. Okay. Now I do accept some laziness, but make sure you at least put the word prop after it. Don't just write distributive. Okay. If you want to write out the word property, feel free, but at least get prop in there so I know that you know it's a property. Okay, so now what's the next thing you would do? Minus 12. Now this is where I save spaces. I just totally eliminate the whole simplify part because I can subtract the 12 in my head myself. You are more than welcome to, if you need to, just do tiny little minus 12s underneath it if you need to, like that, so that you can see arithmetically what you should be doing. But what is 60 minus 12? Is that 48, right? So now line 3 is going to be 48 equals negative 24x. What property did we just use there? Subtraction, because we subtracted the 12. So subtraction prop. Please do not put sub prop, because I will not know if you know means substitution or subtraction. Or subway. Yeah. So make sure you write subtraction out. And then what's the last move you would do? Division property. What is 48 divided by negative 24? Negative 2 is equal to x, which is your division property. Okay? So solving equations by writing out your justification between them. So let's quickly practice this for a little bit. So grab yourself a practice space. We'll pause from our notes. When I say the word more reasons, these would be the things that you would be writing on the right side of your T-chart. So you would have whatever's happening on your statement side and then your reasons on the reason side. So angle addition postulate. Remember the angle addition postulate? It's where we add angles together to equal the whole entire angle, right? So if we had something like, if the measure of angle ABC plus the measure of angle ABC, CBD, then you would have it equaling the measure of angle, will that be ABD? Right, when you add two angles together to get to a whole angle, that's our angle addition. The same thing's true for segment addition. So if AB plus BC, then it would be equal to A to C. Right? If it helps you, we can make little diagrams of this. So you have two angles. So angle A, B, C, and then CBD. So this top plus this would equal the whole angle addition. Segment addition, A, B, C, AB plus BC would equal the whole thing. Okay, so angle addition postulate, segment addition postulate. We've already had those. We took care of them in chapter 1. You actually use them. Okay, perpendicular lines. What are perpendicular lines? If lines are perpendicular, what, then what? Lines are, is everybody okay with me using the symbol for perpendicular instead of writing it out? I'm going to be doing that a lot this year. I'm just going to use symbols. Lines are perpendicular. Remember, this means perpendicular. Lines are perpendicular, then they intersect, right out of space, at a right angle. I'll use the angle sign for my word angle. Okay, so we've got angle addition postulate, segment addition postulate, perpendicular lines. So now what's going to happen, if you look at the next proof, we have two angles equaling a whole angle, which means we're probably going to use which postulate from what we just wrote up there? Angle addition, right? So if you think back to chapter 1 on your test, how did you solve for x? We did this plus this and equal it to the whole degree, right? Well, now we have to actually put it in an actual proof and justify our steps, okay? So whenever you see the word justify each step, you should be automatically making yourself a T-chart, statements on the left, reasons on the right. Okay, and then what is given to us in this problem? Well, the first thing that's given to us is the measure of angle AOC is equal to 139 degrees. Because it says the word given. Right? I'm going to put given over here on my reason side. Alright, so pain about proofs is you need to make sure you put every single step into play. So before I can just start taking x and adding 2x plus 10 to it, I need to actually physically write out the names of the angles that I am adding together. So my second line is not going to be the algebraic expressions. My second line is going to be the name of the angles. So the measure of angle AOB, so the measure of angle AOB plus the measure of angle BOC, measure of angle BOC should equal the whole angle, which would be the measure of angle AOC, which is my angle addition postulate. If you want to just put post with a period for postulate, feel free to do that. Okay. So now that I have my angle addition postulate shown, now I can use the substitution property and actually substitute the values of each of those angles in place. So line 3, what am I going to substitute in place of the measure of angle AOB? X plus, bless you, the measure of angle BOC is 2x plus 10. The measure of angle AOC was given to us as 139. Okay. Common mistakes where students are going to lose points is they're going to forget to do this line 2. Do not forget this line 2. Okay, you got to get that in there. So this was a common case of substitution property. Okay, so now we should be able to do this because we just practice it. What would be your next move? Combine like terms, which would be a simplify. So 1x plus my 2x's would make 3x plus 10 equals 139. So I'm going to write simplify over here. Then we would do what? Subtract 10 from 139, which makes 129. So that would be the subtraction property. And then our last move would be to divide. So that gets me I forgot my x. X equals 43, which is the division property. The original problem asked us just to solve for x, so now we're done. Okay?
Can I go to the bathroom?
Yeah. So, I know, it does seem like a lot of work. But the reason why we do it this way, I mean, you guys are used to solving equations really quickly. But we do it this way so then when we get to actual proofs in Chapter 3 and Chapter 4, you kind of get used to having the back and forth on the left and the right side. Okay? So, don't forget your angle addition there. All right, next page. Got some more properties to add. Almost there. Okay, so now these are new properties that maybe you not have heard of before. Okay, the reflexive property is going to become your best friend. It is used so often in this course that it's just going to be like reflexive property. That's what it is. When you hear the word reflexive, what do you think of? Reflective. Look in a mirror, you see your reflection, right? So you see yourself. Well, that's what the reflexive property is. So when something is equal to itself. So A is equal to A. If we're talking about segments, segment AB, the length of it is equal to the length of it. Okay? So, something is exactly whatever it is. Same thing for angles. Angle A is equal to angle A. I guess I should say the measure of angle A is equal to the measure of angle A, since we're talking about equality. Okay, reflexive property, it's super easy. Something is the same as what it is. Symmetric, now if you think about symmetry, lines of symmetry, right? I did that back in middle school. So the symmetric property kind of has symmetry to it. So if we had something like, we're doing segments, if AB is equal to CD, then CD is equal to AB. So if I kind of thought about it, don't put this in your notes, just watch. If I thought about putting a line of symmetry through the comma and ignoring the then and folded it, the CD would overlay on top of the other CD and the AB would lay over top of the other AB. Do you guys see how it's symmetric? Yes?
It's flip-flopped.
Yeah, flip-flopped. Good. So that's symmetric property of segment lengths. We did it for angles. If the measure of angle A equals the measure of angle B, then the measure of angle B equals the measure of angle A. Okay. And the last one is the transitive property, which is kind of similar to the law of syllogism. It's a little bit more complicated. We have a little bit more stuff going on here. So if we did it segment-wise, if AB equals CD, I would write a little bit small. You need some space here. We got a lot of stuff going on. Bless you. And CD is equal to EF. Now let's think about this for a second. I'm just going to make some drawings down here. Don't put this, just watch. If I have line segment, bless you, AB, and we just said that it is congruent or equal, which is the same thing as congruent to CD, and if CD is congruent or equal in length to EF, bless you, what would be true about EF and AB? They're going to be the same also. Good. So that's your transitive property. So then AB is equal to EF. So what's the link? The link was CD and CD. Just like in the law of syllogism, you take out the part that they have in common, what are you left with? The beginning and the end. Okay, so then the same thing applies for angles. If the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then the measure of angle A equals the measure of angle C. Okay, so the reflexive one's the easiest one to see because you're just going to have something equal to itself. Symmetric, it's just flip-flopped. The transitive property is where you take that common piece in your hypothesis, take it out, and what are you left with? The beginning and the end of it. Okay, so can you identify the following properties for this last example? Hopefully. Can I get rid of this screen? Is everybody okay? All right, so part A, which property do we have? Reflexive, good. Reflexive. Prop. B, what's happening? From left side to right side. It's not one of these. It's an old school one. What happened from the beginning of our lesson? Addition property, good. They added 8 to both sides. Addition property. C, RS is congruent to TW, TW is congruent to PQ, so then RS is congruent to PQ. Transitive, good. Transitive property. And then D, if the measure of angle A equals the measure of angle B, then the measure of angle B equals the measure of angle A would be, well, reflexive has to be exactly the same thing. This is symmetric, right? They're flip-flopping them. If I put in a line of symmetry at the comma and folded it over, the B would overlap the B, the A would overlap the A. So symmetric property. Okay. All right. So I have a few of these to quickly practice.